OWASP is planning the release of the top 10 for 2025 in the first half of next year. Data collection is happening now through donated application penetration testing results and other resources. The OWASP Top 10 Web Application Security Risk is an excellent guidance to software developers and web application security professionals. The most critical web application security risks known in the industry are presented in a consolidated list. Secure coding practices and the business software development culture are greatly influenced by the OWASP Top 10. The OWASP Top 10 in 2021 highlighted 3 new categories and 4 categories with naming or scoping changes. The OWASP Top 10 in 2021 included A01, broken access control, A02, cryptographic failures, A03, injection, A04, insecure design, A05, security misconfiguration, A06, vulnerable and outdated components, A07, identification and authentication failures, A08, software and data integrity failures, A09, security logging and monitoring failures, and finally, A10, server-side request forgery. Going into detail regarding the OWASP Top 10 will show relevance to business application security development. Broken access control moved up to the number 1 spot as the 34 common weakness enumerations, CWEs, mapped to broken access control had more occurrences in applications than any other category. Cryptographic failures focuses on failures related to cryptography, which often leads to sensitive data exposure or system compromise. Injection showed an increase, and CWEs mapped to this category had the second most occurrences in applications, including cross-site scripting. Insecure design highlights risks related to design flaws and the need for threat modeling, secure design patterns and principles, and reference architectures. Security misconfiguration displays that 90% of applications were tested for some form of misconfiguration with consideration for XML external entities. Veracode static analysis, SAS, is frequently used by business software development teams to verify secure coding. Vulnerable and outdated components is a known issue with testing and assessing risk, and the only category that does not have any common vulnerability and exposure CVEs mapped to the included CWEs. Identification and authentication failures include CWEs related to identification failures and note improvements with the increased availability of standardized frameworks. Software and data integrity failures place a magnifying glass over software updates, critical data, CI/CD pipelines without verifying integrity, and insecure deserialization. Security logging and monitoring failures was expanded to include additional types of failures, and any failures in this category can directly impact visibility, incident alerting, or forensics. Server-side request forgery data shows a low incidence rate, above average testing coverage, and ratings for exploit and impact potential, making this number 10 on the list. I cannot wait to see what's in store for the OWASP Top 10 2025 Data Analysis Plan. The OWASP Top 10 2025 Data Analysis Plan goals involve collecting a comprehensive data set for identify application vulnerabilities and enable analysis for the new top 10. Security vendor, consultancy, bug bounty, business, and organizational contributions serve as the main data sources. Information will be normalized to allow for a level comparison between human-assisted tooling and tooling-assisted humans. The analysis infrastructure will leverage the OWASP Azure Cloud infrastructure to collect, analyze, and store the information shared. Contributions to the development effort are attained from known and pseudo-anonymous sources. OWASP has the preference for contributions to be known, as this helps with the validation, quality, and confidence of the data submitted. Information gathered anonymously will be classified as unverified instead of verified. Verified data contribution is validated, but unverified data contribution poses the question if OWASP should support. Data analysis conducted with unverified data will be marked as an area of consideration. There are a few different ways that vital information may be contributed by software developers and cybersecurity professionals. Contributions to the new OWASP Top 10 for 2025 will be accepted until the end of 2024. Data structure is expected to revolve around the time period, total number of applications tested in the data set, the list of CWEs, and counts of how many applications are contained in the CWE. Additional metadata will offer more insight into the current state of cybersecurity testing and vulnerabilities relevant to the business. Cybersecurity experts are providing as much detail as possible so the consolidated OWASP Top 10 may better support business-enhanced risk management strategies. The contributor name, email, time period year, number of applications tested, type of testing, primary code language, geographic region, primary industry, whether or not the data contains retest, and CWE data are all valuable metadata. It is recommended to submit information in one of two separate data sets, human-assisted tools or tool-assisted human. OWASP plans to use Google Forms to conduct a survey in early 2025 to identify the two most significant categories in the top 10. The organization intends to perform some data normalization and keep a version of the raw data for future analysis. The CWE distribution of the data sets will be analyzed with some CWEs reclassified and consolidated. OWASP has set the intention to calculate likelihood in 2025 following the 2021 model to identify incidence rate. Calculating the incidence rate based on the total number of applications tested in the data set compared to how many applications each CWE was found in will improve results. CWSS scores will be developed for the top 20 to 30 CWEs and include potential impact into the top 10 weighted scoring. The contributed data set may be reviewed to identify lessons learned to share with information security and software development professionals.